Today we are talking about DMA 70 and we're going to start with section 2. Section 2 is on multiplying and dividing rational expressions. So multiplying and dividing rational expressions. Just as a recap from yesterday, we were asked what makes a rational expression undefined. And what we determined was a rational expression is undefined if the denominator is a 0. So that cannot be a solution to an answer. We also looked at simplifying rational expressions. And when we did that, what we did was we factored the numerator and the denominator, and then we simplified all that we could. So what we're going to do today with multiplying and even dividing rational expressions is we're going to factor each numerator and denominator. Once we've done that, we are going to simplify by canceling out common factors. And then what we're going to do after that is multiply the results. So, in other words, factor, cancel, and simplify. So, we're going to start with a problem where, in this case, we're not really going to do a lot of factoring per se. We are actually going to do our multiplying first and then simplifying. So when I begin something such as this, the first thing that I want to pay attention to is everything in the top is being multiplied. There's no addition or subtraction. Same thing in the bottom. So I want to multiply the 7 and the 2, the 21. So we want to multiply 7 times 21. So 7 times 21 gives us 147. Now in the numerator, we have an A and a B. We have 2 A's here, 2 A's here. We add these, 2 plus 2 is 4. We have 1 B here, 2 B's here, that's B to the third. In the denominator, we're going to multiply our whole numbers. 3 times 14, we get 42. So we have 42. We have 1A here, 1A here, 1 and 1 is 2. 2 plus 1 gives us B to the third. So if there's no addition, no subtraction, I would not factor to prime numbers personally. The examples in the book do show it that way. I don't like to do it that way. I like to multiply. Now the next thing I'm going to do is look at this fraction 147 over 42. 147 over 42. And then when I press math and enter twice, that reduces to the fraction 7/2. So I have a 7 in the numerator, 2 in the denominator. For my A's, I'm going to use the quotient rule. So 4 minus 2 means I have A squared left. B to the third are identical, and they cancel. So for this particular problem, we are now done. Okay, let's move to another one. Let's say we have 3m squared plus 12m over 6 times 9 over 2m plus 8. Now, what we want to pay attention to is in this numerator, if you will notice, we have a common factor of 3 and an m. I can factor out a 3 and an m, and that leaves me with m plus 4. In this denominator, I can factor out a 2, and that leaves me with m plus 4. My next step that I would look at is when I'm looking at my parentheses that have the m plus 4, they are identical, one on top, one on bottom. So those are going to cancel out. Now I'm going to look at what I have in the numerator. I still have 3m times 9. 3m times 9 is 27m. In my denominator, I have a 6 times 2. That gives me 12. And then I'm going to use my calculator and check. I'm going to do 27 divided by 12. And then I'm going to see if I can reduce that fraction. And that simplifies to 9 over 4. So my final answer is 9m over 4. So as you continue to progress through problems such as this, anything that's multiplication, you're going to factor and then simplify. Okay. When we move into the concept of division, with division, we actually never divide. The first is going to stay the same. The first term stays the same. We change the division sign to multiplication, and then we write the reciprocal of the one on the right. Once we've done that, then we simply follow the rules for multiplication. So if I were to have something such as, if it's first written this way, m plus n squared over m plus n divided by m squared minus mn over m. So the first term is going to stay the same. So this one is the same. Notice it's squared. So what I'm going to do, since it is squared, I would like to write it 2 times to visually see it twice. In the denominator was an m plus n. I'm going to put a parenthesis around it. I'm going to change my sign to multiplication. Now this one I'm going to flip. The m alone comes on top, and the m squared minus mn is on the bottom. Now in the bottom here, I can still factor out an m, and that leaves me with m minus n. Is there anything that we see here we can simplify? Yes. What we can simplify here is 1m plus n on top and bottom cancel. The single m here and the single m here cancel. What I have left on top is an m plus n. What's left on bottom is an m minus n. Something important to pay attention to. These over each other cannot be canceled. I personally like to still keep my parenthesis around the binomial, so I remember that as a whole unit as a factor. That way people don't accidentally try to cancel things out that cannot be reduced. Okay? Let's do one more. Division. Now for this division that I'm going to do, I am going to write exactly what I see for the left term. I'm writing it the same. Okay, so the first one I wrote the same. Then I'm going to write a multiplication sign, and the one that's on the right hand side, I'm going to flip it. So the first was the same. I changed it to multiplication. I wrote the reciprocal. Now what we need to do is to factor all 4 polynomials. Okay? Now, when I do this, I'm going to kind of color code it. It'll kind of make it easier to follow. So for this first one here, I'm going to factor into 2 terms. We've got 1 times 12 is 12, and we're looking for 7. So if we use our calculator, we're going to do 12 divided by x, and second table, our middle number is a 7, so we have a plus 3 and a plus 4. So we have a plus 3 and an a plus 4. After I have factored one off, I like to mark it so that I can see that I have factored it. Let's come to the denominator. I'm going to factor this here. 1 times 6 is 6, and I'm looking for 5. So we're going to do 6 divided by x, second table. We're looking for 5. We get a 2 and a 3, positive 2 and 3. And then mark up, check off that we have done that. Let's change colors. Okay, let's come up here to the top right. I'm going to factor this. 1 times 15 is 15. I'm going to look for an 8. So 15 divided by x, I'm looking for a positive 8. I've got a 3 and a 5. Check that one off. And one more. Let's factor this denominator. 1 times 4 is 4, and we're looking for a 5. And a positive 1, positive 4. And mark that off. So if you see how I had to do this in somewhat of an organized way, I had to factor numerator, denominator, numerator, denominator. The rules, all the stuff that we did in DMA60 that you found to be so much fun. Now, what I'm doing at this point is I'm going to look to cancel out any common factors. Here's an a plus 3, here's an a plus 3. I can only cancel out a pair. I can't cancel this one because there is no other a plus 3 in the bottom. I can cancel out an a plus 4 and the a plus 4 here. They're going to cancel out. And as I look, there is nothing else in the top and the bottom that are the same. So you can leave your answer as a plus 3 times a plus 5. And in the denominator, your a plus 2 and your a plus 1. The order does not matter which of these was first or second, same thing here. It just has to be the same in either the numerator or the denominator. So section 2 is pretty much factor and then simplify. We do have time now. I'm going to go ahead and move into section 3. Section 3 is adding and subtracting. Section 3 is adding and subtracting rational expressions with a common denominator. It's also going to move into skill practices. The skill practices are going to be how to find a least common multiple or a least common denominator. And we're going to focus on a skill practice of how to make equivalent expressions. The skill practices that you're going to be doing are going to be preparing us for section 4. So these two are going to be skill practices. They're not hard to do. It's just doing things for practice sake, like shooting free throws from the 3-point line. Just practice, 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 okay? So let's start with having fractions that have the same denominator. When you have two fractions, if the denominators are the same, you just combine what you have in the numerator. So we have 8c plus 2c over 5d, because the denominator is the same. 8 and 2 gives me 10c over 5d. And since these are all being multiplied, 5 goes into 5 once, it goes into 10 twice. So this reduces to be 2c over, and we still have the letter d in the denominator. Let's try another one. 12x over 3x minus 5 minus 20 over 3x minus 5. So my denominator is the same, which means I can write the numerator, and I would just combine those. Now, in this case, I cannot cancel, I can still look at these and see I've got a common factor. These two both have in common the number 4. If I factor out of 4, I'm left with 3x minus 5. So if I have 4 with 3x minus 5 over 3x minus 5, do I have anything here that can cancel out? Yes, that 3x minus 5 cancels, and my final solution here is going to be just the number 4. Okay, let's do one more practice like this. Let's say we have 3y over y squared minus 3y minus 10 plus 6 over y squared minus 3y minus 10. So we have the same denominator, but what I need to do here, this is a 3y plus 6. What I need to do here is I need to factor this. So we have 1 times negative 10, so that's a negative 10. So clear. Negative 10 divided by x, and we are looking for, what was our middle number? We're looking for a negative 3. Here's my negative 3. That gives me a negative 5 and a positive 2. So a minus 5 and a positive 2. In my numerator, I can factor this. I can factor out a 3, and that leaves me with y plus 2 over y minus 5, y plus 2. Can anything here simplify or cancel? Yes, the y plus 2 cancels. My final answer is 3 over y minus 5. So now what we're going to look at is a skill practice. The skill practice we're going to look at is to find the LCD of rational expressions. Simple steps. We're going to factor only the denominator, and then we're going to determine the LCD. The LCD is the product of all the different factors. And you're always use the one that is repeated the most, or we could say to the highest power. Phew. Phew. Excuse me. So if, for example, if we have two denominators, and I'm just going to write the denominators down. If I have 7x to the third, and I have a 5x squared. To find the LCD, this has a 7 and 3 x's. This one has 2 x's and the number 5. So, as I'm looking at these, I've got to have a 7. This one has a matching pair, 2 matching pairs. Notice, the first one had 3, the second one had 2. I have to use the one that's repeated the most. And then also, the other one had the number 5. So what I need to do is multiply 5 times 7, and that's going to give me 35x to the third. That would be considered my least common multiple of these two. If I have a denominator of, let's say the first one is a b plus 4, and the second one is b squared minus 16. This can be factored. It can be factored into a b plus 4 and a b minus 4. So if I'm looking at these and comparing them, my least common multiple, both of them have one b plus 4. That's the most they have, so we only use one b plus 4. The second one also has a b minus 4, so we're going to use both of those. Okay, let's take this one. For this, I have an x squared minus 10x plus 21, and I have a x squared minus 4x plus 3. Both of these can be factored into two binomials. So for this first one, we're going to have an x minus 3 and an x minus 7. This one is going to factor into an x minus 3 and an x minus 1. So when I'm determining my least common multiple here, both of these have an x minus 3, but only one x minus 3. So I have to have that in my denominator. The first one has an x minus 7, and this one has an x minus 1. So I have to use all of the factors, okay? The next thing we're going to look at in this scenario is that we're going to make equivalent expressions. Now let me first show you this with just a simple fraction. If I give you, let's say, 2/5, and I want you to have a denominator of, let's say, 20. With equivalent fractions, if this is just simple numbers, I'd cross multiply and divide. But to make an equivalent expression, and we're going to have variables, remember we can always multiply any number times 1 and have an equivalent expression. So I'm going to ask myself, 5 times what number gives me 20? Well, that will be a 4. To make one whole, the numerator is the same as the denominator. It's 4 fourths. So if I multiply 2/5 by 4 fourths, which is one whole, I'm going to have an equivalent expression. So here, 2 times 4 would give us 8. So in the problems they're going to give us, for example, 5 over 2x cubed y to the 4th. And all they're going to give you then is equals 8x to the 6th y to the 4th. That's what they're going to give us. They're not going to give us a blank space here. Now, you don't have to write the 1. I'm just doing it right now to show emphasis. You can just put a dot in the line for the fraction. What you're going to do is ask yourself, 2 times what number gives me 8? That will be a 4. If I have x cubed, and this is x to the 6th, how many more x's do I need to go from 3 to 6? 3 more. y to the fourth, y to the fourth, that one's the same. So whatever you have here, you're going to put the same on top, 4x cubed. So 5 times 4x cubed gives me 20x cubed. And when you get to this point, stop. You're finished. I know we've done so much factoring. Once you get here, you want to start back reducing. Don't. Just stop. That's all you're looking to do, is to make an equivalent expression. Okay? All right, so here, let's say we have a 2 over 3, 2x plus 1. Now, this is where I'm saying you don't have to draw the whole big number 1 that I did. And then here we have 6x, 2x plus 1, and an x minus 3. Okay, so we're making equivalent expressions. So to go from the 3 to the 6x, I would multiply by 2 and an x. 2x plus 1 is the same here. What is this missing that's also over on this side? That x minus 3. Now let me show you a little trick that I do. I don't want to put this with 2x and a parenthesis beside because I've got to distribute up here. So I want to take that 2x and write 2x times x is 2x squared, and 2x times negative 3 is minus 6x. So I like to go ahead and multiply that here. So in the numerator, when I now come and distribute, I don't have to go through that process. So 2 times 2x squared is 4x squared, and 2 times negative 6x is negative 12x. And again, stop. I do not want you to go any further. Now, when you have a problem such as this, I want you to notice, as I'm finishing writing this, you will probably be noticing that the denominator on the left can be factored, and it was not factored completely in the original problem given. So what I need to do is to take this and factor out an x, and that leaves me with x plus 6. So now that I have factored this, I have an x here, I have the x here. I have an x plus 6 here and an x plus 6 here. What I'm missing is the x minus 6. So if this denominator is not factored, you factor it and then determine what else do you need to multiply by. And then here we're going to distribute. 5 times x is 5x, and 5 times negative 6 is minus 3. And there you have it. Section 3 is leading up to a lot of fun that we're going to be doing in section 4 when we add and subtract expressions that have different denominators. Thank you.